Hi everyone. In this bite-sized bit, we're going to discuss how to create user-defined methods to validate our code to prevent the user from making errors. Let's go ahead and get started. In our previous discussion, we talked about exception handling, and we added try-catch blocks to our code so that if an unexpected error occurs, we can respond to it. And we did do some specific types of error capturing, like if the user tries to divide by 0, or if the user types a number that's too large, or if there's some sort of format exception error. I like to describe error exception handling as airbags in a car. You hope that you never have to use them, but it makes sense to install them in case something goes wrong. Unlike the airbag analogy, for validation, we're trying to answer the types of mistakes the user might make more specifically. And so I like to think of them as some of the more advanced safety features you might see in a car, like adaptive cruise control that automatically slows your car down when a car in front of you is going slower than you are, or automatic braking when you are about to approach a stationary object, or lane departure so that you don't actually swerve into the next lane with your car. Validation is going to respond very specifically to specific types of mistakes the user is making. They aren't necessarily errors in the sense that the code's going to break, but they are mistakes the user has made in terms of interacting with our program, and we want to let them know that they've made that mistake and give them an opportunity to fix that mistake. So I think of validation as a more custom approach to handling mistakes the user might make. And then I think of exception handling as saving the user from a crash. And they work great hand in hand. I'm going back to my example from the previous video where we're just going to take two text boxes and we're going to divide the first number by the second number and provide the result to the user. In this case, I can envision a couple of things that I would require of the user before they clicked on the divide button. First, I would expect the user to type something in each of the two text boxes. So they have to type something, whether it's a number or a letter, before we can move forward. Second, I would definitely want to check to see that the information they typed in the text boxes isn't letters, that it's some sort of numeric value. And in this case, probably decimal values are acceptable, but you certainly could constrain them to just integer values if you wanted to. And third, something that's probably not required in this problem, but we'll still demonstrate it, is I might want to constrain the range of values that a user can type in a specific text box. So maybe the largest number I'm willing to accept is 100, and the smallest number I'm willing to accept is 0. I could set up those ranges inside my code. These three categories, whether information is present, whether information fits a specific numeric data type, and whether the information fits within a certain range, covers the vast majority of validation efforts we would make inside a program. So I'm going to cover these three basic validation tools in today's example. You could certainly expand upon these ideas, but if you had these three validation techniques, you would handle most of the kinds of input mistakes a user might make on your program. Before we get started, we are going to make a small change to the properties of our two text boxes. For our first text box on our form, our numerator, I'm going to add a tag value. And we're going to see this tag value used in the code that I provide momentarily. And all I'm going to type here is the word numerator. And similarly, for our second text box, I'm going to add a tag property, and I'm going to type denominator. These are descriptors that I'm going to use for the warning messages that we provide in our validation. As far as our code is concerned, I reverted back to the simplest version of our code for dividing one number by another. I've stripped out all of the try-catch, and we're going to add some additional methods outside of our button click to handle validation. Let's tackle isPresent first. This is a method that's going to check to see if the user actually filled in a specific text box on our form. The method that I'm creating is a Boolean method, so it's going to return a true or a false. I call it isPresent, and it's going to be analyzing any text box that I send to it. So any text box on my form could be analyzed by isPresent. The logic on the inside checks to see if the text property of whatever text box we're currently looking at is blank. And if it is, there's something wrong. So I would first pass a message box to the screen that grabs the tag property from the text box, converts it to a string value, and then appends the phrase is a required field. So whatever text box we're looking at, in our case it could be either denominator or numerator, you're going to get a message that says denominator is a required field or numerator is a required field. The next thing that's going to happen is we're going to focus on the specific text box. And this is a great feature of the validation that we provide in these examples. Depending upon the text box that we're currently analyzing, the cursor will be put in that specific text box. So if I'm on the 17th text box in a large form, the cursor is going to be put in the text box where the error actually occurred. Finally, we're going to return a false. We were checking to see if a text box had information in it. It did not, so it failed the test, so we're answering with the false. If none of those things are required because the user did actually type something inside the text box, all we do is return a true. We're going to put this method to use in a moment. But first, let's create our second validation method, which is going to check to see if the user entered the proper numeric data type in a text box. In this course, we typically only look at two numeric data types, integer and decimal. So I'm going to show you both of those right now. You can see that I've created two methods. One is called isInteger and one is called isDecimal, and they work very similarly. I'm still going to analyze any text box the user provides. I'm going to check to see if the text property of that text box can be parsed as either an integer value or a decimal value. So in the first method, I run an int32 try parse and see if I can output properly to a dummy variable called int test value. And I never actually use int test value. What I'm interested in is the true false property of the try parse method. If it succeeds, then everything is good and we'll return a true. If it fails, and you'll note that exclamation point out front, which is reversing this true false value here. So if it fails, we will show a message box that says, hey, this is supposed to be a whole number in this case. And then we'll focus on that text box and we'll return a false. And for isDecimal, if the value doesn't parse as a decimal value, we'd show a message box that says, hey, this has to be a decimal value. And then we'd focus on that text box and we return a false. The last thing we might want to check, and it probably isn't necessary for this particular problem, but we'll demonstrate it anyway, is we might want to set a specific range for the numbers that are typed inside our text boxes. So let's take a look at what that might look like. This method has a few additional parameters. In addition to the text box that we'll be examining, it also will receive a minimum value and a maximum value. So you, as a programmer, get to specify the mins and maxes for a specific text box analysis. On the inside, we'll convert the text property of the specific text box to a numeric value. And I'm using decimal because it's the most flexible numeric data type that we use. And then I will check to see if that value is either too small, less than my minimum value, or too big, larger than my maximum value. If either of those happen, I construct a message box message that says that that specific text box has to be between our minimum value and our maximum value. Then I focus on the text box, and then I return a false. If the value is between our minimum and our maximum, then we return a true. How do we take all of these methods and put them to work? These validation methods wouldn't change from program to program. They're actually fairly generic and flexible. But the specific validation that we need to do for a particular program will change from program to program. So I'm going to create a new method called isValid, and it's going to be different from program to program to program. I've created a new method called isValid with no parameters. And all this is going to do is return a true or a false based upon a series of sub-questions. And the sub-questions are based upon the methods that we created for validation. So in this case, I want to check three things for each of my text boxes. I want to check to see if the user typed anything inside the text box. I want to check to see if the value the user provided was the right numeric type, which in my case will be decimal. and I want to check to see that the user typed a number that's in the range that I'm specifying. And in my case, I'm looking for anything between 0 and 100. This method asks 6 questions, one after another, by using the 2 ampersands after each question. We are asking the questions in sequence. If any of these questions answers as a false, the entire set of 6 questions would be evaluated as a false, but we wouldn't have to ask all 6 questions. If the second question evaluated as a false, we stop asking questions and return a false. If the fourth question returned a false, we stop asking questions and return a false. So we may get some efficiency by setting this up in sequence. I'm also setting up these questions one text box at a time. I'd like the return types for the user to follow the same text box over and over and over again until it's validated, and then validate the next text box from the most generic to the most specific validation. How do we use this isValid method and these validation methods in our actual program? Well, let's take a look. I've made one small modification to my divide click method. Outside of my input, processing, and output, I've added an if question, and I've simply asked, is this data valid or not? If it passes the test of is valid, which we know is asking 6 different validation questions, then I go ahead and pursue my input and my processing and my output. If any of those validation questions fail, I won't actually do any of these calculations. The best way to illustrate how this all works is definitely running with breakpoint analysis. For my first program run, I'm just going to go ahead and click divide, having typed nothing. As I step through my code, we'll see the very first thing we do is ask if all of our input is valid. And for our isValid code, the first thing that we ask is if the numerator is present. So note as our cursor jumps into is present, we check to see if the specific text box has a text property that's blank. We do. So the message box that's going to show up is going to indicate that the specific text box is a required field, like so. Numerator is a required field. Next, the cursor is going to be placed inside the numerator text box, and then we'll return a false. When we return that false, the entire isValid is going to return a false, and therefore we don't do the actual code inside our button. Let's try something else. I'm going to type something inside my numerator, but it doesn't make sense. And I'm going to put my cursor on the second text box to prove that validation is doing some clever things. When I run my divide button and I try to validate, I'm going to ask if the information is present in the first text box, and it is. So I'm going to return a true. Then I'm going to ask the second question, if the txt numerator is decimal. So I'm going to check to see if I can parse that value. And the answer is that I cannot. It does not parse correctly. So my message box is going to tell the user that this value was supposed to be a decimal value. Numerator must be a decimal value. Then I'm going to put the cursor back on the numerator text box and return a false. The entire isValid fails, and my button doesn't do anything. And note where my cursor currently sits, in the text box where I made a mistake. The last possibility is I could type a number that is decimal but too big or too small. Let's try this. If I step through, I can ask if the value is present, and it is. I can ask if the value is decimal, and it is. And I can finally check to see if the value in my numerator text box is within range, and it isn't. This value, DEC test value, is not less than my minimum, but it is greater than my maximum. So when I do an OR statement, that means that this is going to fail, and that means that I'm going to show a message box that says this numerator must be between 0 and 100, then focus on that text box, return false, fail the overall isValid, and return to my form. The same 3 things would happen for our second text box. So we could check to see if it's present, we could check to see if it is numeric, and we could check to see if it is the right range. If I run this, and I'm going to go ahead and just click continue, we'll see that we'll now see denominator as a required field when the first text box passes all of its validation, but the second text box doesn't. And you could test the remaining possibilities on your own. I mentioned at the beginning of this video that validation works hand in hand with try, catch, exception handling. What would that actually look like? Well, we would change our divide click just a little bit. Apologies for the very small font, but I wanted to show what the overall method looks like for our divide click button if I pursue both validation and exception handling. You can see that I added a try block, and on the inside of the try block, I still have the exact same code that we had just a few moments ago, where I validate before I actually do any of my processing. All of that has been put inside a try block. So if an unexpected error still occurred, like division by 0, I would still have my proverbial airbag deploy, where I would catch the division by 0 exception and pop up that message. And we can test that by typing a number that is decimal and within range for our first value, and decimal and within range for our second value, but still get an error message from our exception handling. So we write specific validation for our individual text boxes, but if something unexpected occurs that we didn't account for in validation, our try-catch block would still save us. This is the most robust way that we can handle errors in our code or mistakes that our users might make. So a combination of exception handling and validation is critical for a fully robust program. That's it for this video. Thank you so much for watching. See you next time.